Okay, welcome to 13.4, vertical translation of functions. So in 13.3, we translated objects. Today, we're going to translate functions, but we are like lines and parabolas and other functions. And we are going to do that vertically, up and down. Horizontally, left and right, that type of translation for a function is going to be saved for high school. Okay, so let's review translating of objects. We're going to translate line segment AZ. That's line segment AZ. And we're going to do it 5 units down. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there it is. And it's new points. We can get 2 different ways, right? We can say, well, we can read it. It's at -3, -4. Okay, so A prime, that's the new location, is at -3, -4. And Z prime is at 5, -7. That's one way to do it, just read it from the graph. But also realize when we go 5 units down, we're subtracting 5 from the y coordinate. We're subtracting 5 from the y coordinate. If line segment AZ is approximately 8.5 units, how long is line segment A prime Z prime? Well, this is sort of a trick question. It's 8.5 units. The idea is that they are congruent, is what you need to know. And that is part of the standard. All right, so one function, right? We're going to translate quadratic functions. Now, we learned something similar earlier. We learned how to stretch them, right? If we take f of x, a function, and multiply it by a number like 3, it gets skinnier. We stretch it. And we multiply it by, say, 1/3, we shrink it. We make it wider like this, okay? That's not what we're doing today. Today, we're going to be moving it up and down, okay? Translating. So we're going to use this notation of g of x, right? So the original function will be in function notation f of x, and when we get the new function, we can write it as g of x, simply because g is the next letter in the alphabet. So this is f of x equals 1/3 x, right? The slope here is 1/3, the y-intercept is 0, 0. So we're going to translate it 2 spaces up. So literally you add 2 to the function. So g of x is what we had before, 1/3 x, plus this new variable k, which is just 2 spaces up. Add 2. And so let's see that. So if we're going to go, hold on, we're going to go 2 spaces up with all these points. Right, and draw our new function. Well, that was awful. Let's try again. And so that's g of x, 1/3 x plus 2. So start back at the original one, 1/3 x, and go 5 spaces down. And now since we have a third one, I'm going to call that one h of x, because h is the next letter. So we start at 1/3 x, 5 spaces down, 1/3 x minus 5. Right, we're going 5 spaces down, right? We better be at a y-intercept of 0, -5. Right? All of these should be parallel to each other. Here, let me go 5, 1, 2, 3, 4, 5. Right? They all have the same slope. And that's how you translate a linear function. Right? So this linear functions have been translated. Tell me what happened. Well, we started at +4. That's the one that's f of x. We know that one's first because f's before g. Then we ended up at g of x at +6. So we translated the vertical translation 2 units up. Fill in the coordinates of those new points. So f of x, these are f of x points. -9, 7 is now at -9, 9, right? We're adding 2 to each of the y coordinates when we translate 2 units up. So now we're going to use 0, 6. There's 0, 6 right there when it was at 0, 4. And this is at 6, 4 when it was at 6, 2. All right, so there's our first quadratic function. And we're going to translate that 5 spaces down. So literally g of x is what you had before minus 5. And that will translate it 5 spaces down. You take each of the points, go 5 spaces down. I should be more careful. There you go. And remember, things are still symmetrical here. So that makes things go faster. And let's use a different color here. And do your best to draw the parabola. Right? We're not stretching this. This is the exact same, should be the exact same shape if I was a better artist. And we've translated or moved that parabola 5 spaces down. We took the original one and subtracted 5. Now we're going to go 3 spaces up. So I used, instead of using h of x this time, I used g of x again. You could do it either way. So 3 spaces up, g of x equals x squared plus 3. So you start the original one and go up 3 of each of the points. Right, and we're using the good intersections, but you could use ones with fractions in it, etc. And again, you're not shrinking or stretching this. It's the exact, should be the exact same shape, but moved up 3. That's horrible. Let's try again. That is still horrible. Okay. All right. So when we were learning how to draw a parabola, I mentioned do not make it look like a V. And the reason is there is a function that looks like a V every time. It's the absolute value of function. And you read that as the f of x equals the absolute value of x. Now we will study absolute value functions in another unit. All you have to do here is write g of x and graph it. And the reason we're doing that is because I want to show you that this technique of just adding 4 to the function works for many, many functions. It doesn't work for all of them. But let's look at this. So we had absolute value of x, and we're going 4 spaces up. So you write absolute value of x plus 4. And so the g of x here would be this every point all along here, right? They're all good. What's great about absolute value, they're nice and straight. They make a V. That each point is going up 4 spaces. And you just get another V 4 spaces up. So there's a different question. Domain and range. It's been a long time. So we're going to find the domain and range of g of x, the new one. All right, so think about what are the possible values of x. Well, we have these arrows on the end, right? It's going on forever in both directions. So what's the domain? Yeah, it's all real numbers. Now the range is not all real numbers, right? Think about what are the possible values of y, right? Y can't ever be down here, right? Because we're going that way. We're always going up. So the range here is y is greater than or equal to 4. Want to do the original function, domain would still be all real numbers. The range there, right? Y can't be down there. It's always going up. So y would be greater than or equal to 0 there. Right? Domain, all possible values of x, range, all possible values of y. But that's called a cubic function. Now, I call that the bad chair because it doesn't look that comfortable to sit in. That's a Mr. Ben thing. Other teachers don't call it that. And this is the equation of what you see there. And so I want you to write a g of x for that using the same rule. Well, it would be g of x equals 0.25 x cubed. That's why it's a cubic function. It's got x cubed in it. Plus x squared, 3 spaces up, plus 3. Is that easy? And what would it look like? It would look like that. Now, each of these points, there are not a lot of good intersections here, are going up 3 spaces though. Right? They're going up 1, 2. This is the drawing is not that great here, but that's the idea. All right, so that's the lesson. Let's practice. That's a linear function. So write an equation for that linear function. Well, that's y equals x, but we're using scientific notation. So f of x equals x, right? The y and x, y-intercept is 0, 0. Slope is 1. Y equals x everywhere on that line. You're going to translate that 3 spaces down and write the equation of g of x. So it's literally x minus 3. All right, and you're going to draw the exact same, a parallel line, 3 spaces down. Each point is going down 3 spaces. Find the domain and range of x minus 3. Well, we have arrows on the end. We're going everywhere on the x, all real numbers. And the y, we're also going all real numbers in the y. Right? Linear functions, there are exceptions for horizontal and vertical lines, but the ones that aren't horizontal and vertical, x and y could be anything. All right, so there's a quadratic function. Now, I will give you, you're going to write an equation for this. So it's f of x, and that's f of x, that's x squared. Okay, so now it's, what else do I need to write an equation for that? Well, it's f of x equals x squared minus 8. How do we know? There's the y-intercept, x squared minus 8. Right, 0, negative 8. All right, so now we're going to move that 6 spaces up. So do that. So we're going to add 6, but now we have negative 8 plus 6. So what's my g of x? Hopefully you realize it's x squared minus 2, right? If we move this up 1, 2, 3, 4, 5, 6, now we have a y-intercept of 0, negative 2. And we're going to move each of these points up 6. And they're still going to be symmetrical, 1, 2, 3, 4, 5, 6, and 6. And we're going to write our new parabola, 6 spaces higher, hopefully being the same shape. Find the domain and range of our new one, g of x, it says. Domain is all real numbers. These parabolas look sort of like they're eventually going to start pointing straight up. They don't. They keep going wider and wider forever, just very slowly. But it is not obvious, but it is all real numbers for the domain. For the range, all right, now, it's never going to go down there, right? So those values of y are not possible. So what is the range? Y is greater than or equal to negative 2, right? The range of the original one was y is greater than or equal to negative 8, because it could never get down below there. The parabola goes on forever in this sort of upward and wider direction. There's another cubic function, the bad chair. And we're going to go 5 spaces down. So you don't have to draw the new one. I just want you to prove that you understand this pattern, right? Even for functions we haven't really studied, right? We'd subtract 5, and that's the new equation. right? And it would be 5 spaces down. Right, so this is f of x equals the absolute value of x minus 5. That's what's there now. Now translate that 5 spaces up. Right? So you'd be back to the beginning, and that's what that looks like. Each of these points are 1, 2, 3, 4, 5 spaces higher. 2, 3, 4. Should be a little neater. 1, 2, 3, 4, 5. All right.